The next talk will be about the rise of Move and alternative virtual machines in the Cosmos. Please give a warm welcome to co-founder of Movement Labs, Rushi Manche.
Thank you.
Thank you.
Hey guys, good morning. Thank you guys for all coming out. I know it's the last day and most of the people are probably gone, but we're going to power through and get through it. Some of you guys may have saw the demo yesterday. So I'll go slower because apparently I talk really fast. I got asked if I'm from California. No, I'm from New York. And B, I'm going to focus more on the Move side and explain to you little comparisons of Rust, Solidity, even like Cosmosm. Agenda, just talking about Move in general, some architecture where we're building Movement Labs, and then a little bit more about questions and Q&A. I know there's a lot of developers in here, so we can chat about that. So last year, we saw $3 billion loss of smart contract hacks. The DAO attack was one of the most notorious ones with the large-scale ransomware attack. And the question is, how do we create better solutions for the future? You can either innovate in Solidity, which was most people here probably don't like to do, and it hasn't really been working in terms of ransomware attacks. And how can we really ensure that when we are building DeFi protocols, they're very safe on the smart contract level? If we can build more toolings and kind of create more frameworks around Solidity, but the question is, how do we get the average user, the 19-year-old Stanford dropout, the Oxford student, who can build smart contracts that are very safe, reusable, and easy to learn? So Move was designed by Facebook, the original DM project, to a very intuitive project. The analogy I gave yesterday is Move is to Rust as React is to JavaScript, right? It's a very, Rust is great. Everyone loves it. I come from a traditional Rust background as well. But it needs to be more refined. It needs to be more semantics, more modular in terms of procedures. If we look at more specifics of Move, you have built-in bytecode verifiers, built-in bytecode interpreters. More specifically, this is for Rust, not Cosmosm. I got a lot of feedback about it yesterday. This is more general purpose comparison between Move, Rust, and Solidity. The key value add here for Move is the integration of formal verification. For the average developer, the ability to choose who has access to the smart contract modules is very, very important. If, for example, we look at a DAO attack and research attacks, if you have the ability to say, this hacker who's coming from this angle doesn't have access to this module at specific times, let's say, for example, it's from a withdrawal from a smart contract, you have built-in modular safety that you don't really get from Rust and Solidity at all. Additionally, you have the dynamic NFTs, which is more on the gaming side, which is why you see like Sui and Aptos really proliferating the gaming narrative for Move. You have parallel processing and the ability to swap out traits and NFTs. So let's say, for example, you're a first-person shooter and you're minting millions of NFTs, you probably want the ability to swap out traits at will instead of minting a new NFT each time you upgrade the NFT. So looking specifically at a case study, in August 2022, Reaper Farm Vaults was hacked from oversight in the ERC 420, where an unauthorized user was able to withdraw $1.7 million in funds. The benefit of Move and comparing to Cosmosm as well is you have asset ownership and you can have defined access. For example, if you have a Move vault that can only be moved by specific strategies, the strategies can be say, hey, this strategy can only be modified by a multi-sig wallet by this specific user. You can give it specific account addresses that can modify the vault only. So when you are a developer, especially for newer developers, you have much more flexibility in terms of security. You can define who has access, when they have access, and why they have access. So in the case of vault accessibility, Move would be the most secure language for that. Also on the topic of parallel processing, obviously this is something that Solana started off with, and they kind of pushed the speed narrative, and then the launch of Aptos and Sui also proliferated this. If we are going to onboard the next generation of users and hopefully get to the points of Visa, et cetera, we need to be able to process transactions parallelization. We were talking last night even about this. There are extreme limitations of SDK in terms of parallelizing transactions, something that we're working on with a few teams here. Can we bring a parallelization to Cosmos? It might require some rewriting of the SDK or even launch your own binary. But I think the ability for parallelizing transactions with Cosmos, would usher in more gaming protocols that could really benefit from IBC and integrating with other protocols, but B, also hitting those high TPS numbers that Solana's been marketing for years. In terms of developer growth rate, Move is the fastest growing developer ecosystem in the last 6 months, particularly in the APAC region. So if you go to Seoul, Tokyo, Taiwan, these regions, Move has been really proliferating because A, there's a lot of Rust developers who can pick it up pretty easily, and B, we actually see that developers really want security. Developers really want the ability to make sure their protocols they put time, blood, sweat, and tears into aren't getting hacked for millions and millions of dollars. So a little bit what we're building. We're interested in bringing a Move VM module. Similar to what Evmos did with the EVM module, we want to bring the Move module and get it plugged into existing Cosmos ecosystems. We have no interest as of right now in launching a zone. Instead, we want to build infrastructure to really support Move builders. And kind of if you are building Osmosis, all you need to do is launch on the Move module within Osmosis or Juno or whatever tech stack or ecosystem you're familiar with and get access to Move and the benefits of it. We believe a thesis, it's not even just Move, is no matter what ecosystem you're on, you should be able to customize what language you're building on. It could be Rust, it could be JavaScript, it could be Cosmosm. But when we can have more virtual machines and more frameworks to build on, you attract more developers, which A, brings liquidity because you have more projects building on top of you, obviously. And B, you have more flexibility. So you're attracting developers from different ecosystems, whether it's gaming, DeFi, even different ecosystems like Avalanche, Solana, et cetera. So more flexibility you have through modules, the more liquidity and users you can attract. Our overarching goal is kind of be the center of all ecosystems. So you have Avalanche, but then we have Cosmos, Aptos, and Sui, and really enabling builders to build no matter what ecosystem you're on. A little bit about our architecture. So for starters, we're launching our Avalanche chain next month. We call it M1. But we're looking to potentially obviously enable that and allow us to be essential at routing transactions. So let's say, for example, you have Mars, which is chain A in this instance, and you have interest-bearing token from Lending Protocol, and you have NFT on Chronos or some other ecosystem. We're able to route transactions in a centralized manner. So if you have any Move transactions from any chain in the Cosmos ecosystem, we can make sure they're all being routed to centralized authority so we can index it properly. We can make sure it's in an Explorer, and users have much more flexibility when they're trying to A, build on Move, and C, they can choose where they're building. A little bit about why we started off with Avalanche. The concept of liquidity is something that we're all struggling with in Cosmos, and even just if you're launching a new layer 1, is how do you attract liquidity? And I think the best way to attract liquidity is native bridging. IBC does a great job with this, but there's no guarantee of liquidity. You can launch your own zone. It can be IBC enabled, but the question is, how are you going to track liquidity? With M1, which is our first flagship chain, Avalanche has this concept of war messaging. It's essentially their version of IBC. But the benefit is it shares the same validator set. So for example, if you're a yield aggregator that builds on top of Aptos and Sui, currently you have no yield to aggregate. Aptos TVL is what, 30 million? Sui is like 20 million. I think Aptos is like 40 million now with their stablecoin. That same yield aggregator can launch an M1 and tap into native liquidity, a Manche, Trejo, GMX. These big liquidity giants, for example, an Orbook that launches on top of M1 can create native strategy with GMX. And GMX is probably one of the biggest protocols in the space, period. And the ability to have those options in time for any non-EVM chain to tap into EVM liquidity and user base is very powerful. And then that's what some kind of tech we want to bring to Cosmos. So once we establish the liquidity base on M1, once we can obviously enable that chain, now you have the entire Avalanche liquidity that's at disposal, at the access of these DeFi protocols. It's also IBC enabled. So now you have all these Move Orbooks, all these Move aggregators that are launching on top of M1. A, they can use Avalanche liquidity and tap into the community user base there, and then B, they can create strategies with Osmosis, some of the Vault strategies working on Familiar, a few other players that are really building great technology in the Cosmos ecosystem. So you can be the epicenter of Move development and cross-VM integrations. A little bit about DApp implementation with us. So for example, this is kind of how we're routing transactions. So A, we're going to have SDK, kind of like how we have the Cosmos SDK, but it's going to be like a Move-style SDK on top of that, essentially a framework that wraps around it. And you're also going to have Move modules that launch in partner zones. Then there's all the transactions initiated by dApps. It can be DEXs, Orbooks, et cetera. You have IBC relayers that connect it to our in-house chain. Then your memory pool then goes to current round validator, then blocks proposed and works like any other chain in that the block is settled in instant finality throughout the Avalanche consensus. Here's a little bit of a case study. So that's a team compiles Move bytecode. So a huge struggle that we actually talk about this later in infrastructure panel is how do we build infrastructure that supports builders and other ecosystems, right? Obviously, it's EVM, you have consensus, you have these nice tunes like Hardhat, you have Truffle, Ganache. So when you're going to Solana, when you're going to Move, there's not much tune right now. I learned Move through a Telegram group chat and a YouTube video from like this 4-year-old dude. How can we create the consensus of Move and that we're able to get directly plugged into Capital Wallet, get directly plugged in Core Wallet, which is Avalanche side, get directly plugged into APIs that developers already use. So that's something we're trying to pride ourselves on, and we actually developed this hard at move ecosystem where it's similar tooling to Solidity, but the environment works for Move. So the APIs that you use for Solidity also can translate over to Move, and really helping developers kind of get through this process. Once the transaction is sent, it works for the same address procedure Solidity and Rust 0x0, and then you get compiled into the Move state. And then our Move virtual machine compiles these transactions and takes the execution deployment, does block formation on the end, just like any other chain. And then the smart contract interactions working with different protocols. The one benefit here is that obviously in Solidity you have re-entry, so if you're calling different smart contracts, it can be a lot of bugs that come up through there, hence the re-entry attack. Move has native communication between modules. It's kind of like a hack in that, where you're able to call another module from within your own Move smart contract, so you don't even have to worry about the re-entry vulnerabilities you see in status quo. 3 main use cases for Move. On the DeFi side, it's increased consumer confidence. So if you're building a DeFi app, you're probably not going to get your app hacked for millions of dollars, which is great consumer confidence. On the gaming NFT side, it's particularly attractive, and why we've onboarded many game partners. The ability for parallel processing, so in theory, having 160,000 plus DPS, executing transactions parallelly, as well as dynamic NFTs is very, very attractive. So all these first-person shooters that are coming out, if you're going to be minting new NFTs each time you're upgrading a gun or upgrading a skin, it creates a bottleneck within the chain itself. Instead, what if we can swap out traits? What if you kill 1,000 zombies and you can swap out the mag, swap out the attachments at will? That addresses a lot of problems we saw with DeFi Kingdoms and a few other big games back in the day, where dynamic NFTs could actually save them A, a lot of gas fees, and B, enhance the user experience. And that's what Move particularly brings to the table. Yeah, I think that's overall from my slides. If anyone in the crowd has questions, happy to open up for discussion. I know a lot of developers here. But I think from our side, what we're really trying to proliferate here is we believe in a cross-VM ecosystem, whether it's Solidity, Rust, Cosmosm, and we want to make it as accessible to developers as possible. So we're starting off with Move, but we're potentially working on some Solana VM stuff as well, and bringing it to ecosystems like Cosmos, Avalanche, Polkadot, et cetera. Really want to make sure developer experience is as seamless as possible, no matter what ecosystem you're on. Thank you.
Thank you so much. So we have one question for you. Can a Move contract interact with a Rust contract on, for example, Juno in the future?
Yes, so the benefit of IBC is, for example, if you have a Move contract that launches on our chain, you can invoke bytecodes and invoke functions from other Rust contracts. So it's actually creates this interoperable ecosystem where any Move module can interact with Solidity, Rust, Cosmosm modules, and ensure interoperability. That's why we love IBC.
All right.
Cool.
So thank you very much.
Thank you.
Thank you. Thank you again, Rushi.